Hello and welcome to the second AMA session of Crypto NITT, an initiative by the Technical Council of NIT Trichy. Crypto NITT or Crypto Night has been launched with the aim of creating a blockchain and crypto culture within NIT Trichy. We are proud to partner with Tezos India. Today, we have with us Mr. Aditya Gautam, the tech lead at Tezos. We are delighted to have you with us today, sir. Today's
Hello,
session,
Madhav.
hi, sir. Today's session talks about blockchain based app development. We can start
Sure,
whenever
sure,
you're
sure.
ready, sir.
Okay. So basically, guys, I understand that everybody is in college, so everybody's having this session in college right now. And it's like pretty late, and everybody would be uh, really a boring lecture would definitely flutter you guys out. So definitely, I'll try to make it as interesting as possible for you guys to understand blockchain. And at the end of the lecture, I want any one of you guys uh, be interested and connect with me on Telegram or to connect with Tezos India group and come up with some idea, some crazy funky idea about creating any app application on Tezos basically. So I'll just start with my introduction. So guys, I'm Aditya Gautam. I'm currently tech lead at Tezsure. I've been in blockchain space for past 1 year, and since then the journey has been really great. Learning crypto is really amazing. It's really revolutionary what Web3 has brought for us. So we know every update that comes in the network or every update that comes in the software world or any kind of in any field, it kind of solves some kind of problem. So definitely blockchain also came in to solve a problem. So basically, I remember like 4 years back when I was applying for higher studies. At that time, I used to apply and send money from India to Canada or to US. So I had made so sending this money from India from peer me to a peer at college or the universities was like a tedious process. I mean, it used to take 2 days to get transferred the entire money because of the many centralized authority, and that also I had to sometimes go and activate international banking through the banking solution app that we had and that I had. Then this was very tedious process, and also it used to consume a lot of money as well, like this because of the exchange rates and everything. So that's why blockchain came into existence, I believe. That was one of the reasons that blockchain came into existence. So what blockchain exactly solves is if you want to transfer any kind of any amount from one peer to another peer, you can easily send any kind of, let's say you are using Bitcoin or you're using Tezos, so you can easily send an electronic cash, send money in terms of electronic cash from one peer to another peer easily from one point to another. So within no time it gets credited, and the gas fee or the amount that kind of gets deducted for the network protocol, it's very less. So that's why blockchain came into existence. That was something about blockchain. So why exactly blockchain came into existence? So basically, a blockchain, I would say, a blockchain is a growing list of records, which can, I mean, it's called blocks, and that are linked using cryptography. So every block contains a cryptographic hash of the previous block, a timestamp, and a transaction data. Okay, so for a minute, let me start with the presentation.
Sure, sure. No issues. Take your time, sir.
Okay, so that's our introduction about blockchain and why do we need it. Okay, so that was pretty much about blockchain. That's pretty much about blockchain. So after blockchain, so there are in general, whenever we talk about blockchain, the first thing that comes in our mind is Bitcoin. So we have heard like recently, obviously, Bitcoin rates have been pretty much high, and because of that, it's been into like crowd and masses a lot. Uh, it's been a news every morning. So because of the price up and down. So just like Bitcoin or Ethereum, there is also one blockchain protocol named as Tezos. So when Bitcoin and Ethereum were introduced, they came up with the consensus algorithm. Before going deeper into this, let's tell you about how exactly a development works on a blockchain protocol. So in Web 2.0, what used to happen is we used to have a client that used to communicate with a server, which used to run microservices, or in monolithic approach, a client directly used to communicate with with the controller, and that controller used to communicate with the database. And in the microservices approach, the client used to communicate with the microservices, and that used to communicate with the database, and used to give return back the results as per the client's requests. But in blockchain world, what happened? We removed the entire backend process, the process of maintaining a microservices. Because for deploying your microservices or to deploy your application, monolithic approach, application, you need a server, and that server used to be some you used to hire from either Amazon in terms of AWS, or you used to go with Droplets or Azure. There are various platforms. So in order to remove, so when blockchain came into existence, we said, why not have a decentralized way of running a smart contract or running a service, a backend service, which is known as a smart contract, basically. And what happened is it is pretty much immutable. Whenever you deploy smart contracts, pretty much immutable. So there are various types of blockchain as well, like public and private. So today we'll be talking about the Tezos blockchain. So that is a public blockchain. So when so instead of microservices, as I said, we kind of have smart contracts on the on blockchain protocol. So when Bitcoin and Ethereum came into existence, they kind of came in with a consensus algorithm. A consensus algorithm is an algorithm that kind of regulates the behavior, how the mining will work, or how the blocks are added into the network. So basically, a blockchain is an interconnected set of blocks. A blocks can be a server, or in a server, different blocks. I mean, when you guys must be learning about operating system, you must have heard that every operating system has a different set of blocks, and every block is a block hash and block ID. So this which is unique in the nature. So blockchain is kind of the same itself. So what happens? So as I was saying, so they kind of we were into consensus algorithm. So when Bitcoin and Ethereum came into existence, they worked on the consensus algorithm of proof of work. So a user or a miner, whoever had the biggest like power of biggest which had the biggest computational power in terms of servers. So they kind of had the ability to leverage their power to compute the nuance compute the nuance faster than other miners. So because of which the need of resources kind of tend to be very much higher, and so a lot of resources were consumed in terms of electricity and all. So this kind of also made a one single entity or an entity a complete owner of the system, a complete regulator of the system as well. Not in terms of 51% attack, but in terms of, let's say, whoever has the biggest computational power kind of also has the ability to kind of generate the nuance first, and can add the blocks faster than any other person. So what happened? Any newbie like you and me can't be a miner easily into these networks unless we have a very high computational power to challenge these old to challenge the already existing miners. So Tezos, when it came into existence, they said, let's, instead of having proof of work as a consensus algorithm, let's have proof of stake, a liquid proof of stake as a consensus algorithm. So this kind of solved the entire problem of having higher computational power. So whoever had now the staking power, whoever had the most staking power, kind of had the leverage to add the blocks into the system. So that's why this is the problem that Tezos solved. And also apart from this, let's say when we were when with Ethereum or Bitcoin, whenever there is an update to the network, obviously there are always an update which kind of solves the previous bugs or previous problems that server or these entire network protocols have. So or they kind of bring in new upgrades as well. So whenever there is an upgrade, so there always is a hard fork generated of these networks. So these hard forks are, if let's say if you kind of generate a different hard fork of the main network, then definitely they will always run into the issues. Like this process is very much creating a hard fork of the network is very much expensive process. So which uh, which is directly proportional to the increase in the gas fee of the next upgrade. So that's why Ethereum and Bitcoin kind of, that's one of the reasons why Bitcoin and Ethereum has a higher gas fee. Transaction fees than Tezos that I'll talk later. So these are the some like challenges that Tezos solves. So Tezos, what happens instead of creating a hard fork of the network, whenever there is an upgrade, it has the ability of self amendment. So whenever what happens whenever there is an upgrade, they kind of launch a test net. Different bakers they come in. Bakers are basically miners in Tezos platform, and they kind of come in. They kind of vote for or against that particular upgrade, and then that particular upgrade gets amended to the mainnet hassle free and without any changes or without any updation or any kind of issues in the mainnet network. So these are the few perks that Tezos has. Apart from that, there are in blockchain also there are various. These are the few perks that Tezos has. Apart from that, so there must be a question like in server there are various attacks or various challenges as well. While in centralized system, which blockchain solves in general. So let's say there is one such problem known as the double spending problem, so which kind of exists in a centralized system or as well as in some blockchain system as well. So what exactly is a double spending attack is, let's say I'm a sender A, and I'm sending some transaction, or I'm sending some fees or in terms of coins to a participant B. So I'll, instead of waiting for that confirmation, in even before the confirmation happens, what happens from my end, the amount does not get deducted because the confirmation was never received that yeah, I have successfully transferred from my end to a participant B in the network. And immediately what happens, I send that exact amount to a participant C. After some times, what happens, that network kind of approves that yeah, participant A has sent that particular amount, and then in that case, participant A's amount gets deducted, and that exact transaction of participant A to C kind of gets invalidated. So this is what exactly is a double spending problem. Okay, so Tezos solves this double spending problem. Any blockchain network also like Bitcoin and Ethereum also solves it, but Tezos has also a unique solution. Like it kind of has a ledger, so all the transactions are maintained in the ledger of the network, and if we kind of receive, we kind of wait for 6 confirmations before the transaction, before we kind of validate that particular transactions. That's the works that the Tezos has, as well as this kind of is not unique, I would say, but also it might be it is existing in other blockchain network, but Tezos is solving it pretty flawlessly. Our algorithms are functional based, and then it solves it pretty flawlessly. So there are apart from these, there are various other attacks as well, like Hal, Finlay attack, dusting attack, and 51% attack. So that I'll go through one by one. So there is this Hal Finley attack. So what happens? Hal Finley was the very first person in Bitcoin ecosystem to receive a Bitcoin through transaction. So this guy, he came up with a unique problem that what happens if a miner has two different addresses, A and B, two different the addresses of miners. An address is basically an identity of a person in a blockchain. It can be, it is anonymous in nature, and every address has a unique public key, private key attached to it. Just like you have email ID and password, you have in blockchain network a public key and a private key. That kind of gives you a unique identity in a blockchain. So let's say a miner who is a person who kind of validates the nodes and also adds new nodes to the network. He kind of has two addresses. One and he kind of sends a transaction or does a transaction in between his two addresses A and B. And instead of adding that block to the network, what he does is he does not add that particular block to the network, and he does another transaction from his address A to address C, a merchant. The merchant then, let's say if he's a software merchant who kind of delivers softwares, so that particular miner receives that particular software from the network chain, and what happens now? He adds that particular block which earlier he kind of sent transaction or did transaction into the network. Now the later one who has the latter timestamp kind of gets invalidated in the network. So this attack is known as Hall Finley attack. So now that particular person or miner kind of receives the software free of cost from a party C, merchant C, without giving a single penny. So this is one of the attack that kind of is possible, but for that in Tezos, Tezos solves this attack very easily. Like in Tezos, what happens? A miner, every baker in Tezos, we don't call a person who adds validator a miner. We call them a baker. So every baker, what happens? They kind of lock their funds for a particular cycle, and a cycle is basically a proposal cycle. And for that, a cycle can validate from any n number of days. So for that particular cycle, days in Baker kind of locks his particular funds into the chain, into the pool. So what happens? Let's say if any kind of unusual activity is being tracked from the baker side, his entire funds get seized. So that's one of the ways that Tezos solves this particular problem. Apart from that, what happens is for half-yearly attack to in Tezos, all the stakeholders and the bakers, they kind of all the tokens that all the coins that Tezos has been distributed. 80% of them has been distributed between all the bakers and stakeholders. So only 20% is being 20% is left for the decentralized exchanges to kind of participate into the Tezos network, and to and for any hacker to come in and to do any kind of attacks, they kind of have to gain that 51% of the network. So that's why which with 20%, only 20% of the uh, available stakes, we any hacker can't do that particular 51% attack or any half every attack. And so this is how both of them are both half every attack and 51% attacks will be validated on the Tezos network. And then there is one dusting special kind of attack that was kind of noticed in Bitcoin system. First, a dusting attack is nothing, just let's say you kind of send a very small amount of very small. Let's say in Bitcoin system, the smallest amount is your Satoshi. One Satoshi is like 10 to the power 16, I guess, uh, 12 or 16, I don't remember the exact number, but that's the smallest unit of the Bitcoin. So that's what hacker it does is it kind of sends that small amount to a particular to all the to random addresses on the Bitcoin network. So then what happens? Let's say an organization or an identity is there who kind of keeps receiving this small amount, and they kind of immediately send that or transfer that amount to another person or another. So this way, what happens? That hacker tracks which particular in the ledger where the transactions are happening. So he validates that yeah, this is a valid entity, and that entity no longer remains anonymous on the net. So this is known as the dusting attack. So in Tezos, the dusting attack is like solved how, because we if let's say all the participants are public, definitely or entire blockchain is public, and the ledger, everything can be tracked. But what happens is, if you send some let's say amount to another person, it takes the another person, what happens, Tezos in itself checks first for the confirmation to happen for that particular transaction. It checks six particular confirmation from the network itself to update that particular ledger. So that's how Tezos solves this particular trusting attack. Apart from that, so this is what exactly blockchain was up till now, what exactly Tezos is, and how many attacks are there, and how Tezos solves this particular problem. Now moving on to the next thing, like we'll dive deeper into Tezos, what liquid proof of stake is, and how we can leverage the platform of Tezos to build our products on this particular ecosystem. So basically, a Tezos, as I said, is also a blockchain which kind of works on the consensus algorithm of liquid proof of stake. What happens? Let's say tomorrow you want to build an application, so some calculator. So what you do is you write smart contract and deploy it on the Tezos ecosystem that acts as a microservice or typical microservice replacement, or a typical backend replacement in the of the centralized ecosystem. So this is how exactly we kind of deploy our applications into the Tezos ecosystem. Apart from this, so what then whatever, let's say, transactions or this entire smart contract interaction or whatever deployment we do are all known as transactions. All the transactions on the Tezos ecosystem are governed by liquid proof of stake, which is the consensus algorithm. To generalize in detail what exactly liquid proof of stake is, a liquid proof of stake contains kind of two identities, a baker and a delegate. A baker is one who kind of locks in the fund for a particular cycle, and in return of that receives validation right. I mean, he can validate the the transactions, and he can, that particular baker can add new nodes to the existing ecosystem. Then there is a delegate. But in a typical proof of stake, what happens is there is like a selected number of stakers who are given rights for this validating the ecosystem. While in liquid proof of stake, what happens? A baker, any baker, let's say newbie like you and me, can come into the ecosystem if he has certain amount of pesos, like which is currently around 8,000 days, and he can be a baker into the ecosystem. And apart from that, any delegator. So as I said, any delegator in the Tezos ecosystem. So sorry, liquid proof of stake is kind of distributed into two identities, a baker and a delegator. So I kind of told you like what exactly baker does. Then delegator. A delegator is someone who can give their governance rights to a delegator or to a baker, and instead they can they don't have, instead they don't have to lock their funds that they have. They can easily use their funds all around in the ecosystem. So this is what a delegator does. uh, is the role of a delegator in the ecosystem. So anyone can be a delegator if he kind of wants to, if that particular person or delegator wants to give the baking rights to some person. All he has to, what all he has to do is just if they kind of directly go to some of the exchanges platform, and then they kind of can sorry, not exchanges platform, from on the on platforms that we have, uh, like Better Call, Dev, and they can directly delegate their funds to that particular baker on that on the platform, and then instead they can give their rights as well to that particular baker, which kind of gives them the ability to have to kind of participate in the governance of the on chain. So this is baker and delegate. And so yeah, that's pretty much it about what liquid proof of stake is, and what baker is, and what delegator is. Apart from that, let's say yeah, so how exactly this governance, then we'll come to what exactly how this amendment of the entire Tezos work. So how exactly this entire governance works in the entire Tezos ecosystem is that any entity, let's say, what happens is, let's say tomorrow a new upgrade comes into the ecosystem. New testnet kind of gets released into the Tezos ecosystem. Different delegators, validators, stakeholders, they kind of check how that particular network is solving their issues that they previously had. Like recently, an EDONet kind of proposal has been done into the Tezos ecosystem, and that proposal solved the gas fee issue, the privacy issue. They kind of came in with the set gas privacy. They kind of introduced some new way of having multiple signature in in Tezos protocol, using where we kind of used to have a multi-sig platform, and on the smart contracts now we can like create tickets and distribute multiple signature, multiple authentication easily on that particular protocol. So there are like various improvements that happened. So in order to this improvement, what happens that whenever this proposal gets proposed to the Tezos ecosystem, it kind of gets released in terms of the testnet. And so different validators, stakeholders, they come in, they check it, and different. So there are like forums, there are like voting period, and for that particular voting period, they kind of vote whether or not they like that particular proposal. All the validators, stakeholders, they kind of vote, and for that, for delegators, bakers only vote because they kind of kept their delegation voting rights to particular bakers. So once the quorum reaches like of 80%, then only that particular amendment works into the Tezos ecosystem. So that's how exactly this entire Tezos blockchain works, and how liquid proof, what exactly are the liquid proof of stake, what are the different attacks, what the problems that Tezos solves, and what are the problems that blockchain solves. That's pretty much about it till now. Now, I'll move in deeper into the Tezos ecosystem and other stuff. But before that, definitely I want everyone to understand like whatever I have kind of told till now, what I have discussed. So if there are any questions, guys, like I'll take a short break of 5 minutes, and I'll wait for you to pitch in and have any questions. So Madhav, if any kind of any of the audience has any questions, they
Yeah.
can ask me right now.
So, if anybody has any questions, please feel free to ask in the comment section, right? So we've also been updating about you about all the resources, right? So you can we've essentially talked about bakers, delegators in the Tezos ecosystem. We've spoken about proof of stake, the voting process, right? So we have tried to keep it as concise as possible, and you can definitely check out these resources, which will help you a lot. But please ask any questions that you may have, right? So you can feel free to ask any questions. You can put them down in the comment section.
How many audiences do we have right now?
Uh, we have quite a lot of people who are here, sir. So I guess we can continue now.
Okay. So
Yeah.
basically, guys, like whenever we are talking, like recently, blockchain as well as machine learning has been into like it's been a hot topic recently in the past 3 4 years. And it's not easy to understand and get hold of these things easily. So what I want to do is like I want to make it as much easy as possible for you to understand basically how this entire stuff works. Best way to have a development knowledge is to get your hands dirty in these particular technological stuff. Let's say right now I'm trying to speak about blockchain definitely. So what I expect is after at the end of this particular session, come up with some crazy idea, any crazy idea you have, let's say of any decentralized application that you want to build. So It can be very simple as uh, calculator application or anything. Try to write a smart contract. Since you guys are in colleges, so you guys must have like coded in in Python, and yeah, so it would be easier for you to like write a smart contract on the Tezos platform. So moving on to the next part, what I was, uh, let me share my screen, guys.
Yeah, so essentially now the next part we'll talk about DApp development, right? So
Yeah,
people who
exactly.
want to learn exactly how to develop decentralized applications on blockchain, this part is of a lot of interest for you, right? This is where you will start learning and begin your coding journey as well. So first years who have joined us today, second years, and anybody who has joined us today, this part is the part which you cannot miss at any cost.
Exactly, guys. So till now, whatever there was a theory, like if you that you can read on the internet as well, like just theories they are. So basically, whenever you want to understand any ecosystem or any kind of development knowledge you want to gain, definitely I told you like to have a hand study on that particular ecosystem or that particular development environment. So let's say when right now, since I'm talking about Tezos and blockchain, blockchain, what does it solve is it kind of eliminates the need of microservices and it eliminates the need of having intermediate parties for any transactions. So how it does that? Directly on-chain transactions and through smart contracts. What exactly are smart contracts? Smart contracts are a replacement of microservices in the typical centralized ecosystem. So what we and they are immutable in the nature, and once you write and deploy a smart contract on any kind of blockchain network, Tezos, let's say, so it kind of you can't change it. You can't change or edit it. It kind of remains there for the entire lifetime. So what happens? Uh, so next thing, what we'll be learning is how to write a smart contract on Tezos ecosystem. So since you guys in college, so definitely a way Tezos kind of like Solidity Ethereum works on Solidity. All the codes gets compiled, which kind of gets compiled into the bytecode. Just like that, Tezos work in Nicholson, which is instead of a compiled language, it kind of is an interpreted language. So a functional programming language to be more precise. So a functional, what exactly is functional programming language? So you guys must have had a subject known as formal automata theory, so which was kind of an interesting subject in the colleges. So a functional programming language kind of or a it kind of uses a formal verification method, which is on-chain mathematical logic to validate that particular programming language is valid in nature. So that's exactly what a functional programming language is with formal verification, and that's what a Michelson or OCaml programming language is on Tezos ecosystem. Whatever smart contracts you write, so they kind of gets instead of a bytecode getting deployed on the network, uh, this OCaml code kind of gets deployed on the network, which you can easily track and see on the since it's a public blockchain, you can easily validate and track on the different online platforms that will provide you the links. Just for example, one of them is Protocol Dev, which is pretty much very famous platform. You can easily kind of give your input of the smart contract ID that you have deployed in Tezos blockchain, and you can easily track what functions and what exactly how many interactions has happened in that particular smart contract. That's a leverage of public blockchain. So now moving on to smart contracts, how we can write it, why should we write it? Okay. So basically, let's say I'm kind of want to develop a decentralized application, some application which kind of has a client as a calculator, or let's say a calculator application. What I'll do is I write a smart contract either in Michelson, which is the core programming language of Tezos ecosystem, or there are various for the ease of access of the user. There are various compiled languages as well. Like one of them is SmartPy, which Also, I'll provide you the link at the end of this particular session. So, what exactly SmartPy is? 1 minute. In fact, I'll share my screen and show it to you. So if you guys know Python, you can directly come on to SmartPy platform. You can write your code in Python programming languages. There are various syntaxes that specific to Tezos and smart contracts that are present over here in SmartPy that you can definitely go through on the SmartPy main page in the tutorial section, and you can understand how for example, like over here there is import SmartPy as SP. So definitely I'll importing the SmartPy library, and then you can see over here there's nothing much difficult over here, just some new parameters. Like over here I see like sp dot entry point. So these are some of the parameters that you kind of use in order to define your smart contract uh, in Python programming language if you are coding in Python in SmartPy. So definitely give it a read. Like go to the SmartPy section, go to the tutorials of the SmartPy, give it a read. Like what specific things are there. There are not much that you'll have to learn. Like there are very only few stuffs that are specific to blockchain that is required in order to write a smart contract in Python programming languages using SmartPy. So also, if you kind of go over here, there are various templates, and there are various automatic there are various contracts. Templates are basically a smart contracts like written in SmartPy that you can definitely go through. For example, if I want to go through the smart contract of how the calculator was made, there is an example smart contract like how calculator with a calculator's decentralized application or smart contract would be written in SmartPy, and I can easily go through it. I can understand it. There are then and definitely I can, with the similar approach, I can code other smart contracts as well. So that was pretty much about like what exactly is SmartPy, how we can write smart contracts in the Tezos ecosystem, and what exactly is the language that I'll be using, that in which the smart contracts are basically written in the Tezos ecosystem. Cool. Now let's move on to one of the tools that we at the people at Tezsure have kind of written in order to for newbie developers or any developers around the world to easily kind of interact with the blockchain protocol. They can so let's say let's provide you a use case. So definitely, let's say if you are working on a centralized ecosystem, so what you exactly do is when you go into the industries, or if you are working on your laptop itself, you don't directly deploy any application to the mainnet. What you do is you kind of create a local database. Like you can, if you're working MySQL, you can directly download the MySQL code base and you can run it locally. And if you're working, let's say, on the microservices, so you directly don't code it to the server, you kind of code it first locally, you test it out, and then you kind of deploy it on the mainnet or the testnet for others to kind of interact with that particular microservices or databases as well. I mean, basically to validate that. So just like that, in order to run a local chain of nodes locally, which we call local node, is we kind of created a tool over here by which, leveraging the power of which, you can definitely run a local node in your local system. So one of the tool, there are various tools like Tezsure CLI and Tezsure GUI. So currently I'm showing you Tezsure GUI over here. Like I'm already connected to the local node. Okay, you can while if directly on click of this stop node or start node, directly you kind of can run a local node in your system. And what happens, it kind of creates a local chain in your system, and you can easily interact, create accounts, deploy contract, track the transactions. You can do all sort of stuff over here directly using this particular one. Basically, if you are from Ethereum background, then it's a replica of Ganache GUI. So as you can see over here, I've already opened up my Tezsure GUI. So whenever you fire it up, if you are connected to the local node, if your local nodes are working, then you get a file set of bootstrap accounts, i.e. addresses, and the matrices that are already available for you for testing, just like you have it in Ganache. So what these accounts have some funds associated with it for you to kind of for you to kind of let's say deploy smart contract or do any kind of transactions locally and check out this how check out your this platform and the local nodes like and basically interact with the local node. So there are 5 accounts. So I'll move on to transactions. So you can easily create a wallet as well, restore a wallet as well. For example, let's say if I want to create a wallet called, let's say, new e wallet. A wallet is basically nothing, just an just let's say every person, as I said before, in blockchain has an identity has an identity in terms of public and private keys. And a wallet is nothing, just that particular identity having some amount associated to it. So we call that a wallet, an account having some funds associated with it. So that's a wallet. Just like we have decentralized ecosystem, a Paytm wallet. Every user is there with a user and ID and password, and that user, if he kind of does any kind of transactions, or if he receives or sends fund through that particular ID password, that's known as we kind of termed it as a wallet, a Paytm wallet, where a user's identity is used to send or receive transactions. So that's pretty much it in a blockchain as well. So I'll create a label known as the newbie wallet, and I'll give the password. Or even if you don't give the password, we can easily create a wallet over here. So when I click on create wallet button, I get a set of mnemonics. These set of mnemonics are some pseudo random generated set of words. What it does is it acts as your password. If let's say whenever you are creating an account, every account also has a mnemonic set of mnemonics that you can later on in the ecosystem leverage to restore that particular wallet. Let's say I have created a wallet in a tested account, and then tomorrow I kind of deleted that particular account, or I kind of wanted to add that particular account to another platform. So what happens? I can easily use that particular mnemonic set of mnemonics, password, and then easily I can restore that particular account. So I'll show it to you. Let's say I have copied this entire mnemonics. I proceed, and account gets created successfully. Over here, you can see you can add, since I have created that account, I can easily delete that account from this particular platform as well. So it does not get deleted from the chain, it only gets removed from the platform. So what happens? Let's say an account when it got created, an account was generated which contained address, public key. If I click over here, then I'll see the label, the account, the public key, the secret key, which is the private key, unique to the user. Then there is a public key hash, which is your mainly in Tezos ecosystem, there are like 3 different identifiers for every particular account: a public key, a secret key, and a public key hash. A public key hash is public in nature. Everybody can see on the ledger around which all these transactions happens. So there is this public key hash. Every public key hash starts with a TZ1 address, since we kind of are working with Tezos ecosystem, so TZ. That's why the identifier. So let's say now I want to fund this particular account that I have created. With initially, when we created an account, so we didn't had any funds, so it does not have any funds associated with it. So now I want to fund that particular account with. So what I do is I exactly go to this particular transaction section, and over here I select, let's say, Bootstrap account one, which was containing this, and I want to send transaction or like some Tezos coins to this newbie wallet. What I do is I enter the amount. Let's say I want to send 1,000 Tezos. I can keep this particular gas price. Gas fee is nothing, the fee that you kind of provide to the platform for adding this particular transaction to the blocks. So this is what gas fee is. Fees, let's say when if I kind of give you an example, a typical example as compared to the centralized ecosystem. Whenever you are deploying an application on the AWS server or the Droplets or the Azure platform, what happens? You kind of pay a hefty fee or a yearly fee to that particular platform for using their services. Just like that, we have a decentralized ecosystem where we kind of, for every transaction that we do, we kind of, instead of paying them a yearly fee or associated with them, we kind of, for every transaction, pay them a gas fee, which kind of keeps the system alive and updated, like and incentivized. So I can provide my gas fee over here, which kind of I already provide, like I already populated in the system as 2000 new days. New days is just a smaller unit of days, or I can kind of keep it blank. What happens? I, in the backend, it automatically tracks how much amount, the minimum amount that that this particular amount needs for, in order to get associated to that particular blockchain, like for transfer, basically gas fee that particular transaction need. So I have that particular algorithm running in the background. When I click on this pay amount, kind of transfers that particular fund to this particular account. Click on OK. Now if I go to the account section, refresh it.
So an interesting start over here. So there was a recent update on Tezos. I'm pretty sure that most of you would be aware of gas fees, really high gas fees on Ethereum and stuff. A recent update in Tezos slashed down the gas fees by up to 75%. So it really is a really big achievement. So because gas fees present one of the biggest problems on Tezos platform, on normal general blockchain platforms.
Okay, just a second, please, guys. Like my screen froze for some reason. Oh, I meant.
So please feel free to put any questions over here. We can take them right after we're done, right? We will answer each and every question. And any ideas you guys have for dApp development, you can put them down over here as well. We would love to hear about them.
Mother, can you see my screen right now?
Yes, I'm able to see the screen, sir.
My screen?
Not your screen, not yet.
Yes. Okay, right. Now can you
Yes,
see the screen?
yes,
Okay,
yes.
okay, okay, okay. So pane of Windows. Okay, so basically we were done with transactions. So guys, if you have any questions, you can ask me for time being. So I'll take a short break, like 1 or 2 minutes.
I get, yeah.
Okay, are there any questions, Mother?
Uh, yes, so Jairam S says that if we have any ideas, he'll update us. Sure. So you can interact with Mr. Aditya through his Twitter account, right? There's a lot of Tezos updates that get posted over there, right? So
So,
you
okay, so guys, like I kind of have my own blog post, and in my Twitter handle, I kind of am very active. So over there, I keep posting about any new upgrades or any new changes in the protocol that has been happening. So there, if you follow me on the Twitter, then definitely you'll be also you can also keep track of the Tezos ecosystem. But basically, what I this the meaning of this session is to for you guys to come up with some have some any crazy idea and to create any decentralized application uh, leveraging Tezos blockchain. So for that, if you want to connect with me or the connect with the entire team of Tezsure or Tezos India, we have a Telegram channels through which you can interact with us. So that's the medium by which you can definitely interact with us. So till now, I have so I'll continue with this. So till now, I have shown like what exactly is accounts or wallets in the accounts. What are their IDs and why are they existing in the Tezos ecosystem? And I showed like how we do transactions when I do transactions and what happens like how I transferred these from one account to another account. So there was this newbie wallet that was there, and as you can guys can see over here, so that when I sent like 1,000 new pays this particular account, it got updated over here. Although this entire transaction was happening locally, it got updated, and so this entire entity it kind of exists only in your local system and not on the testnet or the mainnet of the Tezos. So apart from transactions, what I have is, let's say if you want to come up, if you want to learn Michelson code, like how exactly this entire functional programming language they work, and directly if you want to, let's say, since you guys, if you are from computer science background, so you guys must have coded in massive machine assembly level languages and all. So if I kind of show you an example, it is also kind of I would say similar, like but different in manner. So you can see over here. So every in a Michelson, since I've told you like it's a functional programming language, so you can see there are various set of uh, defined keywords that you kind of can go to nomadic labs. There's this online website where you can go and learn about it. What exactly is Michelson? Do you have that link model? Guess this one is the old one.
Yeah, sure. I'll put it there in the chat.
Okay, okay, okay.
Yeah.
So you can go through that particular link that Madhav will post about Michelson, and you can go through the entire code base, what these different parameters defined over here are, and how you can write smart contract coding in Michelson language. Like OCaml is pretty much a rare language as well. Like not much developers are there. If you are developing in OCaml, then definitely you'll have that perk that you are kind of one in a million. So definitely that's the perk that you'll get in Michelson and everywhere wherever since the space with which the Tezos ecosystem is growing. If you're a Python developer or a Michelson developer, definitely uh, you'll get a lot of challenging jobs as well. So that's the perk of learning these languages. So over here, if you go to the editor is basically a section where you can write your code. You can code your smart contract in the Michelson language correctly. I have also put down like various example contracts, a calculator, Nesto, and a fungible token one. You can directly click on the drop down, click on them. You can directly then, if you want to compile over here, kind of gets compiled. All the so it will show you like if any errors are there, directly it will show you to the output monitor. And then once the code is compiled without any errors, you can directly deploy it to the deploy section. Select any wallet. Let's say I'm selecting over here bootstrap account. Can give any labels to that particular contract. Let's say this was an escrow one. Escrow. Okay. The gas limit is, as I said earlier, like over here, the gas that you kind of pay as a platform fee for the smart contract to get deployed on the main. And apart from that, I also have given an initial storage that you can change later on. This initial storage is nothing like basically every smart contract kind of works in every smart contract in Tezos blockchain kind of accepts a parameter, which is initial parameter, which is kind of is used to initialize the smart contract on the Tezos initial state of the smart contract on the Tezos chain. So when you are deploying the smart contract, this initial storage will go in the storage section, and what will it will all these values will get updated over here. You can see over here this balance. So is the balance zero, and then there is a balance of the owner, like owner balance, and there is an address of the counterparty, which is this address. So there are like this kind of gets populated automatically when you compile the smart contract over here. So then what I can do is I can save and deploy the smart contract. It kind of gets deployed successfully. So you can see over here, it kind of got deployed pretty much really fastly because we were kind of running a local chain. So a new block easily got added and the smart contract got deployed. And all the smart contracts in Tezos kind of starts with KT1, KT2, and KT3. So this goes. Now, if you want to track that particular smart contract, I can go to the contract section, see the list of the smart contract that has been deployed, that I have deployed over here, list of add smart contract. And if let's say what happens is tomorrow I want to let's say add another smart contract, a deployed smart contract with the smart contract address into this particular list, what I have to do is I just go to this contract section, and then you can easily add that smart contract into this list of smart. But in local node, all the you can't add a new smart contract of the test. Hence, over here it's not a clickable icon. So that's why if let's say a smart contract is there deployed in the test net or in the mainnet, then you can add that particular smart contract in that particular uh, network type. So over here, if you kind of see the drop down, there are various RPCs available. An RPC is just a URL of that particular baker where the bakery is running. And it also, let's say, if I want to deploy a smart contract or do any transaction or create an account in the testnet, then I'll kind of fetch any baker's RPC address and I'll kind of add it in the settings section over here with a label with a network RPC. An RPC is basically a small URL where the nodes of the baker are running. So that particular URL I'll kind of can add it over here. And then since there, let's say if you're working on the testnet or mainnet, definitely you want to track the smart contracts or your accounts, how many transactions has been done, or what what was the last updation or when timestamp or whatever changes has been done in that particular account or everything. Then you can use the TZ Stats Explorer endpoint. So if you TZ Stats is a platform. If I go over here and if I search for TZ Stats, so this is a platform where you can track all the smart contracts. That also provide you an RPC of their own, which you can go into their API section over here. You kind of directly over here you can see API endpoints. These are the endpoints where they kind of are running their own RPC, which service where they are kind of running their own service, which kind of keeps the track of the ledger, whatever transactions has been added, or whatever contracts have been deployed, and everything. So you can select your RPC, respective RPC. Let's say I want to kind of add a test net, or which is test net to my RPC. Then definitely I'll copy either Delphi or Carthagnet and I'll paste it over here in the base question. Windows. Okay, so that's how I add the RPC URL. Meanwhile, when the development environment is getting started, so as you can see over here, there are various network names which kind of has been defined for different. I mean, which has been defined over here. So basically, a mainnet always represents the main network, which is i.e. the main nodes, the blockchain, Tezos node that are running, and all the other, let's say, Delphinet or Carthagnet are the different test nets that are running in that particular ecosystem, and they kind of have their own specific upgrades, which kind of huh, they kind of have their own specific upgrades, own features that kind of is being proposed in the latter, like as a solution of some mainnet drawbacks, or some as an upgrade to a mainnet protocol. So these are the various RPC names, sorry, network names over here, and relevant to them are the RPC URLs. So recently, let's just the Delphinet and Carthagnet are some of the old protocols. Delphinet is the recent one, but after Delphinet, there was an ADONet proposed, and yeah, so that's also one of the test nets that you can leverage. Every testnet has their own unique perks, and own unique gas fee, or some solutions to the previous problems, which they kind of solve in their own way. So as I was saying about editor, like how you can write smart contracts over here, deploy it, and then they can go to the contract section where you can list add contract, remove contract. Then you can set up your RPC. Let's say I want to set up an RPC with a label, let's say new P, and I want to add the mainnet RPC. So in order to track, I can add it over here. And in order for the bakers, let's say I want to add a baker's RPC for the network. Definitely, what I can do is I can select a baker. Let's say we are in Tezsure, we are running our own bakery as well. So we have our own bakery address for mainnet. So that we can put it over here, and we can create, check the network type, like which one it is, mainnet, Delphinet, or local. Then we can click on save icon, and immediately it kind of gets validated and added to the drop down list. If you can see over here, the mainnet movie RPCs got updated over here. So you can select this particular network type, and immediately what happens, this entire application, it updates the entire states. The accounts gets updated over here. Let's say these are the two accounts that I had in the mainnet, got updated. Now if I go to the local node, you can see list of the local accounts that I had created locally. So these are the different how you can interact with this particular tool. Basically, this is a developer tool which helps you interact with the Tezos blockchain. So just like any third-party tool that you use in order to write your queries in the data. So for example, let's say a dbeaver application, or any kind of application that you want to that you use in a typical centralized ecosystem to write your queries, to interact with a database. Just like that, this is one of the developer tool, which is kind of is used to interact with a different network of Tezos ecosystem. So local node, they don't have RPCs to kind of track. Definitely, it's locally running locally, just a replica. But if you kind of go to the mainnet, you can easily track all the latest blocks that are running. So right now, let's say this new RPC kind of had no blocks added. So if I kind of go to the smart by one, say, you can see that it kind of pops up the different transactions that recently has been happened on that particular network, different block ID that has been created, hash that has been generated with the timestamp and everything. That's pretty much it. How this entire tool works. You can create an account, do the transaction, write a smart contract, track your smart contract, set your own RPC URLs, and yeah, and if you want to, let's say, connect with us directly, we have a Telegram group where you can, let's say, if you face any problem with that tool, then directly you can report it over here going through this particular link. Or if you want to contribute to the GitHub section, all our codes are open source, completely open source. So if you want to, let's say, raise any issues, requests that you want to be solved into the next update, you can directly report it over here. Or you can go to the, if you want to start development, or if you want to fork this particular repo and start your own development on top of it, you can easily go to this particular repo. Entire source code is open source. Fork it, start working on it. If you need any help, directly you can contact us through the Telegram channels. So that's pretty much it. How you can do any kind of you can interact with the Tezos blockchain protocol. So
Yeah.
I'll take a small pause over here, guys. And if you guys have any questions, you can definitely write it in the comment below.
Yeah. So we had one question over here, asked by Bandhavya. As blockchain can be private, can a company replace their DB2 database ledger with blockchain? Will it provide any advantage to do this way in terms of performance to load and report?
Mhm. So, so we kind of already, if you want to want to search about any blockchain or any decentralized storage medium. So, first of all, like blockchain is not a storage mechanism. It's just it's a replacement where you it's a set of networks or different blocks where you write and deploy your smart contracts. But if you want to, like, let's say, search for a decentralized replacement of storage mechanism, then you can search for IPFS. This is one of a kind, like where you can store a NoSQL data over there. So it's also distributed and it's kind of decentralized. So that's one of the, one of a kind where you can, which decentralized storage that you can leverage to store your data store your data, NoSQL data. So the question was like, replace a DB2 database ledger with blockchain. So definitely any companies, what the very first thing that they want to do is they want to, any company, when you kind of go into any of the companies, like any take an example of any companies, they, what they do is they first try to target their business, which means that they first create a balance sheets, they check what their business is and what exactly solutions do they require, which one is the cheapest one, so that they can leverage the cheapest solutions, and not only cheapest but also the best one. So, for example, let's say if right now storing storage as in a decentralized way is not as cheaper as databases, centralized databases, but in future, if they kind of become as cheap as them, so then companies will definitely think about replacing the databases, the typical centralized databases, with the decentralized one. Of course, it kind of in terms of performance, it does not affect the performance. I mean, I have used the IPFS myself and I haven't seen any performance issues. In fact, if, let's say, if you are kind of from a centralized ecosystem, then you always run into the problem that you kind of have to create replica master slave approach, which kind of a master slave approach or a replica of the database to create which kind of works makes the database scalable. But in decentralized storage mechanism, you don't have to think about scalability or anything because it's decentralized. All the whatever data you push, it's kind of stored in the entire nodes. So that's the perk that I kind of see in a decentralized storage mechanism. Any other questions, guys?
I think that's it. So, yes, so any other questions you guys have, you can always join our Discord community, right? All the updates regarding the Tezos resources, whether it be the questions, applications, all will go out through the Discord community. So, we'll be putting the link down here. And anything you would like to end with, sir?
Nothing as such. So, guys, I hope, as an introvert myself, I was able to explain most of the stuff to you guys. So, basically, what I wanted to do was like definitely make blockchain easier for you guys. If I was successful in doing that, then well and good. If not, guys, you can easily reach out to me and on the Telegram channel that Madhav will post. We are always welcoming any rogue ideas as well. Like I told you, any simple application, if you want to build it. I can provide you the links, how you can start with the development, how you can create your own decentralized application on the leveraging the Tezos ecosystem. And if you kind of have a unique idea, let's say something different, so and you want to talk to me or any the person from the Telegram channel, you can directly come to the Tezsure Telegram channel, and then you can post your idea, or you can have a one-on-one chat with me as well. But to consider that I always reply late, and most of the time I'm offline. So if you're an introvert like me, you can reach out to me as well. Follow me on the Twitter channel. I always kind of keep posting. I have my own blog posts and every other stuff, so you can kind of follow that on Twitter uh, to keep be updated on the Tezos chain. And one last thing to contribute, Tezos is very new. Like not a lot of products are there. So this gives you leverage to all the students out there. Like
To develop.
in the past time, you kind of have a lot of free time. Right now, you guys are studying from home. So if you have any free time, then definitely go to the Ethereum website. If you find any product that you can easily replicate on the Tezos ecosystem, go and build that. Will help you out with all the required resources and every stuff. And that's it. That's pretty much it.
So, thank you, sir. We'd like to thank you for coming today and telling us so much about the Tezos ecosystem. I hope whoever joined in learned a lot, right? And we would like to remind the community that, again, this is just the beginning. We have a lot more rolling out for you, right, in the coming days. Do join in the Discord community, and we'll be posting all the updates and the resources over there. And thank you. Thank you, sir. Thank you for
Thank you.
everyone
Thank you,
for tuning
Madhav.
in.
Thank you, guys.
Thank you.